Hi everyone, Kyle here, and I hope your day's been going well so far. Today's video will review one method you can use in solving a system of equations, the so-called equal values method. First, let's review what a system of equations actually is and what it means to solve one. A system of equations is simply a set of two or more equations which use the same variables. In order to solve a system of equations, we must find the values for the variables which make all of the equations in the system true, or in other words, the solutions which are shared by all of the equations in the system. On a graph, this would appear as the intersection of all of the equations in the system, with the point of intersection being our solution, a point shared by all of the lines in the system. When we're trying to use the equals values method, we first have to make sure that the same variable is isolated on one side of the equations. In this example, we have two equations with the x variable already isolated. Since we have x equals 4y minus 9 and x equals y minus 3, it makes sense that since both equal x, 4y minus 9 and y minus 3 would also equal each other. So with that, we can create a new equation, 4y minus 9 equals y minus 3. If you want to get technical, this is called the transitive property, where if thing 1 equals thing 2 and thing 2 equals thing 3, then thing 1 is also equal to thing 3. Getting back on track now, with our new equation, we can solve for y, and we'll find that y equals 2. We're not done yet though. We still have to find the x value of our solution, and for this we can simply substitute the y value, which we just found, back into any of the equations in the system. Once we've solved the system, you can also double check your answer by evaluating the x and y values you found into the other equations in the system which you haven't used yet. Now let's get on to the fun part, the practice problems. Pause the video here and have at them. Welcome back. Let's start reviewing now. Problem 1 starts us off nicely where we can immediately apply the equal values method since both equations already have y isolated. By setting the expressions equal to each other, we'll get negative 3x plus 4 equals 3x minus 2. Solve for x, and we'll see that x equals 1. We'll now plug this value back into one of the original equations, and then find that coincidentally, y is also equal to 1. In order to check that our answer is correct, we can substitute these values into the other equation in the system that we haven't used. And if it holds true, then our solution, 1, 1, is correct. Yay! For problem number 2, we have to do a little bit of work in order to isolate y in the first equation here. All we really have to do though is just subtract 2x from both sides. We'll get y equals 5 minus 2x, and we're good to go. We can set the two isolated expressions equal to each other, and we'll get x minus 1 equals 5 minus 2x. If we solve for x, we'll get x equals 2 this time. Repeat the same process, plug it back into one of the original equations to solve for y, and we'll find that y equals 1. We can once again check our answer by plugging those values into the other equation in the system, and we'll be happy to know that our solution 2, 1 is correct. Now for number 3, since both equations have x isolated this time, we can simply set the expressions equal to each other. However, when we try to isolate y, we'll find that, or we'll end up with 7 equals 15, which if we think about it, is just not really possible. 7 can't equal 15. So when we get something like this, it means that there is no solution. And in 2 dimensions at least, with your x and y plane, this is because the lines are parallel to each other, meaning that they will never intersect and that there are no common solutions or points between them. If we were to alter the system a little bit and we had a system with 2 equations which were the same, we would end up with instead 7 equals 7, which is always true. 7 is equal to 7 all of the time. This means that there are infinitely many solutions, and if you didn't already guess, since these equations represent the same exact line, every point on that line is a solution of both of these equations in the system. And as there are infinitely many points on that line, we will have infinitely many solutions. That's all for today. And don't worry if it's difficult at first. Make sure to just take your time in trying to understand how these systems work. Just have a great day. Take care and always ask questions if you have any.